Okay, to finish out our exponent rule review, we're going to look at 3 more exponent rules that you'll need in order to be successful in our exponential function unit. So let's take a look at the first example. We have 3 halves, a fraction, and that's being raised to the third power. So just like any other exponent rule, we would take our base of 3 halves and we'll use it as a factor 3 times. Now, looking at this, we can see some similarities to a previous example. Here we have 3 factors of the numerator. We have 3 factors of the denominator, which then would allow us to rewrite the numerator and the denominator with that exponent, then allowing us to simplify to 27/8. So looking at this exponent rule, if we have a quotient and that quotient is being raised to a power, shorthand form is that we can take the numerator, give it the exponent, take the denominator, give it the exponent, and then simplify from there. The second exponent rule we're going to look at involves taking a product and raising that product to the power. So just like the previous example, we're going to take our base of 2x and we're going to use it as a factor 3 times, which then gives us 1, 2, 3 factors of the numerical coefficient, as well as 3 factors of x, then allowing us to simplify further to 8x to the third power. So the exponent rule tells us that if we have a product and that product's being raised to the power, we can take each factor of the product and give it the exponent. So the factor of 2 would be raised to the third power, and the factor of x would be raised to the third power. And then from there, evaluate the exponent to simplify the expression. The next exponent rule we're looking at is involving something with a negative power. Now, based off of what we know about exponents, it really wouldn't make a lot of sense for us to take 2 and use it as a factor -3 times. So the negative exponent rule stems from dealing with the reciprocal of the expression. So technically this 2, if we changed it into a fraction, would be 2/1. In order to evaluate the negative exponent, we end up taking the reciprocal of the base, which would be 1/2, and that exponent of 3, through the movement of moving that term from the numerator to the denominator, makes the exponent positive. So thus allowing us to simplify 2 to the -3rd is equal to 1/8. So anytime we encounter something that has a negative exponent, we're really talking about finding that guy's reciprocal. So the last example we have to look at involves, again, a fractional base now being raised to a power that is negative. So building off of the previous example, the first thing we're going to do is we're going to take the reciprocal of the fraction to make the exponent positive. Then from there, we can expand that out, 3 factors of 2/3, which then allows us to go back to our first rule that we looked at, 2 to the third over 3 to the third, giving the numerator the exponent, giving the denominator the exponent, and then simplifying to 8/27. So this is kind of a combination of 2 rules. The first thing we're doing is we're taking the reciprocal to make the exponent positive, and then we're applying the exponent to both the numerator and the denominator.